Hey there, thank you for clicking on this video to see how to do our assignment, how to build a stable atom. You're going to see how to build unstable atoms too. But the most important thing is I want you to build two kinds of hydrogen and each element up to 10 different isotopes. That means different number of neutrons for each element. Sound hard? It's not. But I'm going to show you how to do it. So click on symbol, this middle one here, and you'll get this. Okay, now on your paper here in this column, protons, I want you to have two of every element. Now, elements are different by the number of protons they have. So one is hydrogen. Let me show you that. If you have one proton, you have hydrogen. If you have two, helium. Three, lithium. Four, beryllium, and so on and so forth. For every time you add a proton, you're changing the name of the atom. So let's start off with one and see how many kinds of hydrogen, how many isotopes of hydrogen are stable. And so you have one hydrogen here. And so one thing else you got to do is click on stable. And it'll show you whether it's stable or not. This is stable, but it's not neutral. See, it's got a plus charge. Hydrogen is plus, or protons are plus. Electrons are minus, so if you have the same number of protons as electrons, it's going to be neutral. So let's drag that up there. Now we have a neutral atom, and which is neutral, and it's stable. So there we got our first one. So on your chart that you're either doing online on the Google Doc, or maybe you've printed it out, you can come in and see me. This has one proton, one electron, zero neutrons, there's no gray ones, and the atomic mass is one. See this right? That's a scale. It says it's one. So it's one proton, mass of one, and it's got a neutral charge. And so the mass here is one. Every proton and neutron one weighs one. Every proton neutron weighs one. So let's see if we can have another isotope of hydrogen. There we go. So, and it's still, the charge is still zero. So let's write this down. One proton, one electron, one neutron. The mass is, though, how many? One plus one is two. Two, and there you see that here. So in the final column, you'll write down 1, 2, 0 with that H right there. Okay, well, just for fun, let's see what happens if we add another neutron. It'll still be hydrogen, but it's unstable, so we can't do that one. Okay, let's go on and add another proton. If we add a proton, it becomes helium, and it's stable. However, the charge is plus one. How are we going to make it zero? Well, we have two pluses, so we need two minuses. So we'll add a minus there. Now it's neutral, and it's stable. So we're going to write that down. Two protons, two electrons, one neutron. Now two protons plus one equals three, and that's why that's three. So it's got two protons, that makes it helium. Three because it has one neutron added to it, and its charge is zero because we have one electron for every proton. Now, what's the basic rule that you've kind of seen so far? Right here, if you have this close to the same number of protons and neutrons, it's going to be stable. So you've got to go through this for all the first 10 elements and find out what is the magic combination. So let's do the last one where you're going to have to do it yourself. Write it in yourself. We're going to try another neutron. Boom, there's our second isotope of helium that works with two neutrons. Does it work with three? No, it's unstable with three. Okay, and when it's unstable, that means it's radioactive. So we just want stable ones. How about for